Alright, I want to talk today about verification of indefinite integrals here for a few minutes and do a neat little example, a rather tricky example. Before we get started, if you're unfamiliar with the differences between definite and indefinite integrals and what they're used for, go ahead and check out my video, integrals indefinite versus definite or something along those lines on my channel, and that should clear everything up for you. So as a quick little review here on talking about indefinite integrals, indefinite integral is just going to take the integral of some function dx and it's going to spit out the antiderivative. Antiderivative is exactly the same thing as the indefinite integral. They are synonymous with one another. So basically what the indefinite integral, the antiderivative, is asking is, what function, when I take its derivative, gives me f of x? So something prime is f of x. What is something? That's all this is asking. So if f of x is 2x, then we know that the indefinite integral of f of x dx is going to be x squared, because when I take the prime of x squared, what do I get? I get 2x, so that's what would go right there. So that's all we're talking about here with indefinite integrals. So let's go ahead and get started. What if, now you're given a problem and you're told, I want you to take the indefinite integral of x over the square root of a plus bx dx. And you do a lot of work, and you come out with 2 over 3b squared bx minus 2a times rad a plus bx, and all this just plus c. So this is your final answer, and you're asking yourself, you don't have access to a Wolfram Alpha or anything like that, so you're asking, I don't know if this is right. What can I do to determine if this is right? So let's apply a little logic here. If we said that the antiderivative is just asking what function, when I take its derivative, gives me f of x, then are we not simply saying this function's derivative is equal to this right here, because this would be f of x in our indefinite integral? Yes, we are. That's correct. So if we can just differentiate this, then that should give us this, if we are correct. So if we take the prime of all of this and we wind up with this, then yes, we did everything appropriately and we know we're in good hands. But if we get something different, then we know that either we made a mathematical mistake in differentiating, or our problem is wrong. We made a mathematical mistake in our integral, and our answer is wrong. And this is not the antiderivative. This is not the indefinite integral. So that's what we need to do. So at this point, now that we've understood that, the only real skill we need is the ability to differentiate. So if this function over here were something like 3x plus 6 or something that was a or negative sign, something that was a joke to take the derivative of, then hey, we'd be in good hands. It wouldn't take much work. But this is a really nasty function, right? Taking the derivative of this it's kind of ugly. Even if we were just to take the derivative of this, it's not that big of a deal, but taking the derivative of this is horrible. So let's go ahead and get started. See what we need to do here. Well, first off, this function, I think the best thing we can do is let's go ahead and rewrite it, okay? This is going to be, let's just put 3b squared on the bottom, because all of this other stuff is just over 1, right? Of course it is. So since it's all over 1, we can just, we're just multiplying that times 1, then we multiply that times 1, then times 1. So the bottom can just stay 3b squared, and we'll put our little c over here on the end, and I'll talk about why we're doing that in a minute. Equals x over rad a plus bx. Okay, and we've got over here 2 times bx minus 2a radical a plus bx. Okay, so we've taken this and we have arrived at this much nicer little function here that looks a little bit better. So what do we need to go ahead and do? Well, I think that a good first step is to differentiate this by term, and the first thing we should look at is the derivative of c here. So all of this prime should equal that, so that means that since this is a sum, this is just the derivative of this plus the derivative of this. Well, the derivative of this is c prime, right? Well, c prime is just 0. So this is the same thing as just 0. This goes to 0, so we're ignoring it. It doesn't matter anymore, okay? We get rid of this c, we don't care about it. I'm sorry, I can't write this 0 appropriately, evidently. There we go. C no longer matters. So now all we're looking at is this jazz. So let's go ahead and start worrying about it. Well, what does this look like over here? This looks like the this looks like the constant derivative rule, which says c times f prime is just c times f prime. What is the difference between these two things? The prime is being applied to everything, c and f here. The prime is only being applied to f here. So this is basically saying if we have a constant times a function, its derivative is that constant times the derivative of that function. So a practical example of that would just be, what is 2x prime, right? Well, 2x prime is just going to be 2 because it's the constant times x prime, which is just 2 times 1, which is 2. So that's what we're talking about here. So what we can say is, since this is a constant rule, we have 2 times all of this jazz over here, then we know that, here's what we can say. We can just keep this 2 on the outside. So I'm going to go on to a new page and write how this is going to look now. Here's what we've arrived at. Now we've got 2 times bx minus 2a. Make sure I'm right. Bx minus 2a, great, correct. Bx minus 2a times rad a plus bx. Okay. Great. So you got this. All of this, though, is prime, right? Yeah, sorry, tech glitch, not letting me write here. So let me see if I can do a straight line. Okay, great. So that should look like prime enough. So now it's 2 times bx minus 2a times rad a plus bx, all of this prime. And, of course, that's just going to be over 3b squared. Yeah, 3b squared. Okay, so 3b squared. So hopefully we're following everything pretty well up to this point. So now we've got this. Now what do we need to do? Well, we need to use the product rule, of course. And we're going to use a weird kind of product rule here, okay? We're going to use a product rule with a U and V substitution. I've got a video on U substitutions that would be good to go ahead and check out if you're unfamiliar or shaky about how those work or what we use them for. So we use U substitutions to make integration easier, and we're going to use it to make this derivative a little bit easier here. And so what we're going to do is, here's the normal product rule, right? F times G prime is just equal to F prime G plus F G prime, okay? So this is the normal product rule. Here's our amended product rule. We're going to say that d dx of uv is equal to v du dx plus u dv dx. Now, what does this mean? Just watch. This is really not that terrible. So we're going to call u here equal to bx minus 2a. Because we have so many variables floating around, it's just going to get confusing otherwise. And we're going to call v equal to rad a plus bx. Okay? So here's what we're going to do. This isn't technically a u sub, but it's really kind of close. So uv. Okay, so hopefully these two terms look differently enough. Alright, so if we do this, then here's how the new function is going to look when we write it. It's going to look like this. And, let's switch to red to make this a little bit easier to look at. I want to see, is this, I guess that's, I don't know if you can see that or not. Let me mess around with some other colors here. I don't like that either. Purple. Yikes, everything looks ugly on this background. Orange. I guess we'll have to stick with white. My bad. Alright, so, or not white. Is white okay? 2x plus. Sorry, I'm wasting time here. Let me just stick with black and stop with this stupid nonsense. Alright, so back to black here. No pun intended. Okay, so 1 over 3b squared, right? Times 2 times bx minus 2a, okay, times radical a plus bx prime plus radical a plus bx times bx minus 2a prime. Now, this should look extremely familiar, and it should look exactly like our original product rule. We just had to go and do an extra step in just calling some things u and v here to make it a little bit easier for us to figure out what we were going to be putting in each place, because f and g might have been a little confusing there. So, cool. And using our original form might have been a little difficult. So now we've got this, and it should look familiar at this point. So now we're going to go in and we're going to just differentiate each of these sums by term, because we've still got primes here to take care of and primes here to take care of. So let's go ahead and take care of those primes, and we'll start this on a new page. So here, when we rewrite everything on the next page, we're going to be, I know this is looking a little messy, but it's a difficult problem. We're going to be factoring out constants while we differentiate the sum by terms. So we're going to be doing 2 steps at once. So now all this is going to, let me see if I can carry this over in my head. We're going to have 1 over 3b squared times 2 times, I think it was rad a plus bx. A plus bx times, and then we'll be factoring out a b from this b, so we should be factoring out, hang tight, b times x prime. Okay, cool. I think then that would be minus 2a prime plus, let's see, yes, minus 2a prime plus bx minus 2a times rad a plus bx prime. So now we're going to use, now we've got all this, and we're going to need to use the chain rule. And in this case, our chain rule is going to look like this. Here's a little aside here. Our new chain rule is going to be, not our new chain rule, but our amended chain rule for the format of this is going to look like d dx for rad a plus bx, in this case, is going to equal d rad u over du dx, where in this case, and I probably needed more room, where in this case u is just going to be equal to a plus bx. Okay, so where u equals a plus bx, and of course this should look familiar from over here. A plus bx, in our new form now that we've differentiated by term and all that, and sorry, stupid watermark is going to mess us up. Let me come over here and write this, and our du rad u, looks like rad a, rad u is going to be equal to just 1 over 2 rad u. Okay, so now I will explain what all this means here and how this is going to apply. So in this new form here that we have, that we're using for our chain rule, all of this, and forgive me for the how slow this is going, I'm trying to carry over from one page to the next in my head, all of this is going to turn into 1 over 3b squared times 2 times, okay, now we're going to have a rational. We're going to just have bx minus 2a times the prime of a plus bx prime, I believe. Hang on. Yes, okay. Over 2 times rad a plus bx, which should be our u, and this is going to be added to rad a plus bx times, factor it out, b times x prime minus 2 times a prime. Alright, so let's make these parentheses and everything appropriate. Okay, now this should be our new function, and everything should look correct. Let me check myself here. Let's see, bx2a plus b, move to bx. Yes, okay, everything looks good. Okay, so now that we've got that, I know this has a ton of steps. There's 16 minutes into this one problem just to take a derivative, but this is using just about every rule imaginable. So now that we've done that, using our special case of the chain rule here, now we just need to start simplifying things out. So all of this we can simplify to 1 over, and you know what, we're just probably going to need a new page once again. So let's carry this over 1 over 3b squared. And of course, we still have that 2 times rad a plus bx. B times x prime, okay, minus 2 a prime plus, and of course the same rational but slightly different, which should have 2 times rad abx on the bottom, rad a plus bx. Okay, and then on the top, bx minus 2a, then the derivative, so bx minus 2a times a plus bx prime. Okay, great. So yeah, this looks good to me now, finally. All right, so now we've simplified that. Now our derivative of a here is just going to go to 0. So we'll turn this all into 1 over 3b squared, 2 rad a plus bx times bx prime plus 0 times negative 2 plus, yeah, because we're going to need another rational. So yeah, let's just put this on the next page. This is a very, very, very laborious problem. So we simplified down to this, which is going to just, okay, so we said derivative of a is 0, so we'll rewrite this with that new knowledge, so it should be 1 over 3b squared 2 times rad a plus bx b times x prime plus 0 times negative 2 plus, and then our rational will be bx minus 2a times a plus bx prime over rad 2, no, 2 times rad a, okay, 2 times rad a plus bx, okay. Whew. So, we're getting slightly slower, so let's just simplify even more. Well, what can we simplify to this? Well, we'll just need more rationals. So we're going to have a rational within a rational here, and then just continue to simplify. So all of this is going to simplify out to 2 times, okay, let's just make one giant rational with 3b squared on the bottom, because we can do that now, and then just have 2 times b, okay, so 2 times b, and you have the advantage of being able to take screenshots here, I'm hoping. A plus bx, okay, and that should be a times x prime, I believe. Yep, okay, plus, and now we're going to have another bloody rational. On the bottom of that rational will be our 2 rad a plus bx. Okay, and on the top we should have our, this is what we're going to put on the top, so our bx minus 2a times the derivative of a plus bx. Oh, yikes. This is an awful problem. A plus bx prime. I'm sorry, there's the button there that takes you to the next page, you know, so a plus b x prime. Okay. Whew. So, all of this huge, ugly rational within a rational, which is typically something we hate to have, all of this is equal to, well, let's see, we still have prime, so let's differentiate these sums by their terms and factor out constants. So all of this should just, and we'll have our 3b squared on the bottom, so we should have just another giant rational here. 2 times, bx minus 2a times a plus b, a prime, a prime plus b times x prime over 2 times a plus bx, and right now all we're just doing is more simplification, differentiation, and all of this plus, and you know, we can go ahead and write our denominator. We know this is going to be 3b squared, and all of this plus b times rad a plus bx times x prime. Whew. So we've taken that, turned it into this, and okay, come on. All of this is equal to, go to another page here, try to remember this. So all of this we can simplify some more. We'll still just have 3b squared on the bottom of a huge rational. So I'll just make that the whole page, because I'm going to need it anyway. So that can be simplified to 2 times b times a plus bx, rad a plus bx, x prime, where I'm going to need way more room. Two times b times rad a plus bx. Did I say x prime times? Yep, x prime plus another lovely rational, but the bottom of this rational should just be 2 times rad a plus bx. I think Yep. And then on the top, we're going to have our bx minus 2a, I believe. So, yeah. Bx minus 2a times the derivative of, ooh, now this is nice. Okay, so we're going to have a derivative within a derivative here. We're going to have the derivative of a plus b, x, yeah, because we have the x prime there. So a plus b, and then x prime within that derivative. Okay, cool. So a plus b times x prime. Whew. So we have all of that. And now let's see if we can simplify any more. Well, okay, we can. We just can now. We can finally take x prime as just being 1 because we've had to look at each variable separately up until this point. So now we can accept a prime. Not a prime. Whew, my brain is turning to soup here. X prime is just 1. So x prime is just 1. So that's going to leave us. Let me simplify this for a second. Okay, so that should be 2 times. We're going to have it in our 3 on the bottom. Okay, so this can now be rewritten as, rational 3b squared. Whew. And because we can accept x as 1 now, where x prime is 1, we're still going to have our big 2 here. Yeah, let's rewrite this up at the top. We'll have our 2, and then we can, everywhere we have x prime, we can just rewrite that as a 1. So we still have 3b squared in our denominator, but our top is going to be 2 times, God, we're going to have another rational here. So, yeah, bx minus 2. Whew. So bx minus 2a times is 2a times another derivative in the derivative, our a plus bx prime over 2 times a plus bx in the rad, a plus bx in our radical, plus b times rad a plus bx. And, okay, let's simplify this even more. So we'll continue having 3b squared in the denominator, and we'll continue having our 2 here as our coefficient we're multiplying everything else by, and we will need bx minus 2. Okay, so this is going to still be the same. We're just going to have bx minus 2a times a plus bx prime over 2 times a plus bx plus b times rad a plus bx. I don't think we changed anything. Okay, no, okay, so we need to just, yeah. Okay, I think we simplify as much as we can here. We need to go ahead and let a be a constant and equal 0. So that's going to, okay, great. This is finally going to start making things a little nicer. Looking, well, not by much, but okay. So if the derivative of a is 0, then all of this can just go to 3b squared on the bottom. 2 times bx minus 2a times b times, okay, x prime plus nothing. Nice. Okay, that's good. On the bottom with 2 rad a plus bx, 2 rad a plus bx plus b rad a bx, a plus bx, I think. Yep, I should be having this pretty well memorized at this point. On like our 50th screen, I think. Probably actually screen number 12. Okay, so now that we've got that as our 0, let's just rewrite everything without that 0. So 3b squared on the bottom 2 times, and this is 2 rad a plus bx, I believe, and then bx plus 2, no, not plus, what's minus 2a? Yeah, bx minus 2a times b times x prime, plus b times rad a plus bx. And all right, so now derivative of x is 1 again for our final remaining x prime. So that will simplify this down a little bit, but only by a little. Okay, so all of this is going to equal. Oh, that's ugly. Sorry. All this is going to equal. We still have our 3b squared on the bottom. And our 2 times, and we'll just, yeah, okay, 2a plus bx, that will just be, we can have that on the other side. So now we'll just put this on this side, our b times rad a plus bx plus, and we'll keep our ugly rational, which should be b times bx minus 2a, b times bx minus 2a, yeah, because that's just 1. So b times bx minus 2a over 2 times rad a plus bx, rad a plus bx. Whew. Okay, so that's taken care of. All over 3b squared, so let's just simplify some more. Still have our 3b squared on the bottom. Still have our 2 here. These facts remain. So b times bx minus 2a. Bx minus 2a. And we'll still have, now we'll take a prime of x again. 2 times rad a plus bx plus b times rad a plus bx, I think. Oh, man. A plus bx. Yep, okay, great. So now we can take this final x prime. I said final last time, boy, was I wrong. This final x prime as being 1, so we'll rewrite it again on our 16th page of crap. I'm not bitter. This problem is just getting old, so I think I picked a terrible one to show you guys. So 2 times b times rad a plus bx. I know I'm going to start rushing and make a mistake. Okay, nope, that seems fine. Plus b times bx minus 2a, b times bx minus 2. Yeah, because this x prime is just going to go to 1, so we don't have to worry about it. So we're just multiplying by 1. So that was b times bx x minus 2a over 2 times rad a plus bx. 2 times rad a plus bx. Okay. All that over 3b squared. Okay, and I think, let's just simplify this a little bit more, and then just, my goodness, we're done, right? So let's simplify this some more, and we should get 3b squared on the bottom times 2 on the top, b times rad a plus bx, yep, b times rad a plus bx plus rational 2a plus bx, b times bx minus 2a. You know what? Yeah, this is as simplified as this is going to get. So actually, I think we only have one more step. Let me see what we were originally working with here. Back to our initial function, and we wanted to know if that was x over rad a plus bx, and let's see. Yes, that should simplify. So x over rad a plus bx. So hang on, let's see how we can get this to simplify down to that and see if our problem is right. So 3b squared is 2. So yeah, it would be when we still have this rational over here. Okay, so yes, yeah, this will simplify down. This was a terrible example, but eventually, if we want to continue doing more algebraic junk for 3 or 4 hours, we can get this huge, ugly thing to finally just simplify back down to x over rad a plus bx. Okay. So, yes, it is possible, and yes, this is what we got for our original thing. So a quick recap of what we did, and the word quick should have nothing to do with this video or this problem. 34 minutes for one integral verification. But we wanted to figure out, we took the antiderivative of the indefinite integral of x over rad a plus bx, and we got that it was 2 over 3b squared times bx minus 2a times rad a plus bx plus c. And so we said, how do we know if this is right? We said, let's just take the derivative of this thing, and that should give us this. And if it does, then we're right. So, and I paused the video a minute ago and verified this independently via Wolfram, so I know this is correct. And it does simplify down to that. But, yep, so we took all of these steps, these long, miserable, horrible steps, to finally get at the derivative of that function, and it should have been, see, procedural stuff. I did miss some steps there, just putting this caps on the end, these parentheses, excuse me, they have to be closed. Okay, so we did that, we did all these big steps, and we finally got this answer right here, and yes, we're right. We're finally done. So this is the correct answer. This is the derivative, and the derivative is what we got in the integral. So the derivative of our result is our antiderivative of the integral, that matches up with the integral. So poor wording there, but anyway, all right. I typically say at the end of these videos, that's all there is to it, but that really doesn't apply here. This was a bear of a problem, but at least we got through it. So that's all there is to it.